Most engineering software gives you a number and asks you to trust it. Aura is built on a different idea. It connects gas film coefficient calculation, rotor-dynamic screening, validation evidence, and decision gates into one reviewable workflow for aerostatic and gas-static bearing rotor systems. In the bearing workbench, the engineer defines geometry and operating conditions. Aura computes load capacity, stiffness, flow, eccentricity, and cross-coupling terms. These coefficients are not isolated outputs. They are exported into the dynamic workspace for further calculations. Now the coefficients entered the dynamic workspace. I'll keep the live calculation visible because Aura is not a static report generator. At this stage, the exported support coefficients are carried into a rotor model. Aura evaluates how those bearing properties affect critical speed behavior, forced response, and stability indicators. Then the result is interpreted through evidence gates. The question is not only what the plot shows. The question is what this result is allowed to prove for an engineering decision. The Campbell diagram gives critical speed screening and operating speed separation. Everything converges in the decision engine. Aura separates a completed dynamic run from an engineering release. Here, the model is ready for review and several physical checks pass. But the overall verdict remains conditional, and the freeze level stays screening only. Damping evidence is still screening level, bearing-to-rotor coupling is one way, and no case-level benchmark or experimental trace is attached yet. Aura allows review, but it does not release the design until the evidence is strong enough. The validation layer is public. Aura shows the registry release, Zenodo DOI, and 2 engineering evidence anchors. For the journal holdout, maximum residual is 10.28%, mean residual is 3.77%, and leakage audit passes. Aura turns engineering trust into traceable decisions.